I've been doing technical interviews at the company I work for almost 2 years now. And the one thing I keep noticing is that a lot of developers get uncomfortable once the conversation moves to deployments. We can talk about architecture, APIs, clean code, scaling, no problem. But when the question becomes how you actually deploy this, the answer is often, well, we have DevOps person for that, and that's fine. A lot of teams work that way. But I still think every developer should understand the basics of how their application gets deployed, runs, and survives outside their laptop. Here is our demo application. We will manage list of cities. We'll store city collection in the database. We'll have web API with CRUD operations to manage list of cities, and we'll have UI for that. We also will have a long-running processor which will basically update or uppercase name of a city in the database. Let's check local environment setup. First of all, we need Docker. I will use Podman in this case. We also need Kubernetes. I will use Kind. All the scripts will be written in PowerShell, and I will run everything on Windows. So my local run is following. We have source code. We have build scripts to build locally. We'll produce couple container images and start containers from that images in a local Docker setup. We'll have container for UI, for API, for database, and for long running process. Let's check local run. Let's start running up locally. For that, first of all, we need to spin up database. Database is ready. Let's check our Podman. We have containers and Mongo database already up and running. Next one, we'll have scripts to build our API. API is ready. Now let's run it. And of course we can test our web API. So here we have get request, which give us version and the container name. Cool. Now let's try to make an API call to get list of cities. Here we have couple already seed in the database. We also can create new city, London, and let's get once again. We have new city added to the database. Let's check Podman. We have demo API container started. Cool. Now we have processor, and this processor works in the background and updates or uppercase city name. So let's first of all build our processor. Let's run processor image. It will start update three cities in a database. Let's get current state from the database. We have 3 updated, 1 left. Let's run once again. It should update only 1. Cool. Let's get. Everything should be updated or uppercased right now. Cool. Now let's build our UI. Let's start UI. And let's check what we have in the web browser. We see our web API. And we also should see front end with a list of cities. Let's add new one like that. It's been added. Let's try our processor. Updated. Let's refresh on the UI list of cities. Yep, everything works good. Now let's check what we have in a local setup. We have one container with a database, one container with web API, and one with a UI. The same should be visible in Podman. We see all the containers, everything is up and running. So basically that's our local setup. Because when it comes to integration tests locally, we always can start everything with a Docker Compose in order to have all the services up and running. Let's try Docker Compose. It will rebuild images and restart complete application. Let's grab URIs to test. Works fine. Let's try UI. Works fine. We can add some city. If we start processor, it will process and uppercase city names, so everything works fine. I have a feeling that a lot of developers stop right here and don't go further with their deployments. What we will try to do next here is to simulate production deployment with Kubernetes. I will run everything locally on my laptop, but you can apply the same principles to any Kubernetes cluster in any cloud or any on-prem environment. First of all, we need to create a Kubernetes cluster. I will use Kind for this. Let's check our schema for the Kubernetes cluster. We will build images locally and images with our API, UI, and processor. We also consume image from the public repository for our database and create a namespace. Inside the namespace, we will place a config map, service, and stateful set for our database. Next, we will create deployment with couple instances of our web API and service for web API. We'll also create couple instances of the UI in a deployment and service for the UI. And finally, we will create cron job for our processor. So here is our initial setup. And let's start creating as mentioned, I will use Podman and Kind. Right now, I have nothing configured here locally, and I will start building my own cluster. For that, let's create a cluster. I will show you configuration of that cluster. We need it for publishing ports for our API and UI. It seems we are ready. Let's check in Podman what we have now. So we have our control plane. We have one node and basically pretty boring, empty, brand new cluster for our tests. Let's start deploying. So first of all, we can rebuild our images. I will use scripts for that. Let's rebuild our API. API is ready. Let's rebuild UI and processor. Okay, processor done. Next, we need to add some extra stuff inside our Kubernetes cluster. First of all, we need to install load balancer. For that, we'll use a couple other scripts. MetalLB is almost ready. And one final step, we need to apply configuration for our load balancer. Done. Next, what we need to do in our cluster is to upload images into it. For that, I will, using Podman, unload images into tar archives. Here is API, UI, and processor. Our complete images unloaded into tar files, and we can start loading them into the cluster. Okay, with that, our local cluster is ready, and we can proceed with deploying our applications into cluster. For that, we will execute our first deployment. Let's check our YAML file. Actually, if we compare our Docker Compose, where we have database, API, UI, and processor, basically the same things, but in Kubernetes terms we have in the deployment. Here we have our demo namespace, all the services and everything is deployed inside the namespace. Then we have config map. We have service for our Mongo database. We have stateful set with our database. We have deployment for the API web services with 3 instances of API service. We have service for our web API. Next, we have deployment of our UI with 3 instances and service for that. Finally, we have cron job with our processor and with schedule. It means that our processor will be executed each minute. Which is most important part here is we have specification with the limits, with the resource limits for our instances. This is exactly how it will be deployed in production. Nobody deploys a container with unlimited memory and unlimited resources for it. It's always restricted. We will repeat our production deployment here locally. So let's start deploying our deployment. Here it is. Let's do kubectl apply with our deployment. Let's verify our deployment. What we have, it's running. We have 1 database. We have 3 APIs. We have 3 UIs. Container still creating, probably with a database. It's pulling its image. Let's wait for all of them to be ready. Okay, finally everything is ready. We have 1 instance of the database. We have 3 APIs, 3 UIs, and 1 processor. Let's check our services. Beautiful, services are up and running. And if we would like to see everything what we have currently in our cluster, we have pods, we have services, we have our deployments, 2 replica sets, stateful set, cron job. That's our API serving from the Kubernetes. In the GET request, we have instance ID of the instance which generated response. If I try to refresh a couple times, we probably no. Okay. Now let's open our front end from the Kubernetes. It seems everything works fine. Let's see what we have in Podman. We have in the demo namespace, we have 2 deployments. One deployment for API with the 3 ports, one deployment with the UI with the 3 ports. Here is list of our ports, 3 APIs, database, processor, and UI. We have services for database, API, and UI, and we have our cron job. Beautiful. Everything is ready, and what we can do, we can try to test services from the Kubernetes deployed. That's our tests for the API. As you can see, we are getting responses from the different instances. We have 3 instances and they basically randomly respond. Let's try to test API. UI. We have UI version 1 with a blue background. Beautiful. Everything is up and running in the Kubernetes cluster locally in the same way like it will be deployed on production. Now when we have our application deployed locally, let's talk about updating or releasing new versions. First release strategy we'll check is a rolling update. So let's grab the README for that, and rolling update is something like that. The idea is we have one service and couple instances behind this service, and we have new version of the service. What we start doing is replacing old instances with new instances. For example, our expected state is 3 instances with a version 1 of our web API. When we need to deploy version 2, we create new instance, and service will target or spread traffic among old and one new instance, and then it will destroy old instance. On the next step, we will create another one instance of the new version of the web API, and all one will be deleted. And finally, in the end, we'll have only 3 new instances of the web API. Let's try this in practice. So what we have here is a rolling update demo. And as a prerequisite, we need to have our application up and running, like our current or old version of the application. Everything works fine. We have our front end and web API, and everything is good. Let's imagine we simulate usages of our web API from the external users. So here each second I run a web API request, and in the response we see which version of the application generated this response for us. Cool. Let's see what's inside our cluster. Let's get our pods. Okay. We will starting creating a new version of our web API. So first of all, let's imagine that in the API we have our new fancy development, new feature released, and what we will do, we will increase version of the API. Cool. Now we need to build new API version 2 locally, and we will prepare our version 2 image to be uploaded into the demo cluster. Finally, upload image. Okay, our image is ready, and we can apply our new version in the cluster. let's check status of that deployment. Finish 2 of 3. Here it's create our demo API successfully rolled out. Let's get list of our pods. What we have? We have old in the terminating state. We have new already running. Let's check again. Still terminating. Check again. Final one terminating. Oops, some error. Okay, everything is done. We have new version of the API deployed into cluster. Let's check our consumer. Okay, here, before deployment, we got responses from Web API version 1 only. Then we started to getting responses from the version 2 and with version 1 together. And finally, right now, we have responses only from the version 2. Nobody basically mentioned that we had a deployment. All our Web API works as it was before. Right now we have responses only from the version 2. And basically that's the idea of the rolling updates. What we can do next is try to check what Canary deployment is. For that, let's grab the description. Canary is when we have both old and new applications running together all the time or as long as we need. We have rules how many traffics to route to old versions and to new version, and basically keep only small portion of the incoming requests going to the new version in order to understand if we are happy with, for example, in this case, version 3. So in this demo, we'll create Canary deployment of our web API. Only 25% will be routed to the version 3, and all the requests, or most of requests, will still be served by the old, in this case, version 2 version of the API. As a prerequisite, we need to have everything deployed and version 2 in this case of the API up and running. We will run our monitor in order to see which version generates response of our web API. In this case, it's version 2. Next, we will do amazing development of our web API, and with releasing new features, we will increase version of the web API. When we have new version, we need to build our new container. Okay, container with the version 3 is ready. Let's make it available for the Kubernetes cluster. Okay, and let's apply Canary deployment of our web API version 3. Let's check what's inside our deployment. API Canary, with this name it will be visible in our console. It's starting from the image web API version 3. Cool. Let's apply. Let's check status. We see another one instance of our web API with a Canary in it. We have 4 web APIs right now, 3 version 2 and 1 version 3. Okay, we already can check our monitor. So, demo daemon, okay. So most of the responses we have from version 2 and only small part of the responses in the version from the version 3. Okay, we can keep this deployment as long as we need in order to verify if we are happy with the new version. And if we are happy and if everything is fine, then we can just roll out version 3 in this case. Let's also check Canary traffic. I have special test for that. Okay, oops. I have special test for that. We'll execute 40 requests. Here are requests from the version 2 and responses from the version 3. Okay. Only 15% were served by the version 3. Let's try to repeat this test. Okay, cool. 17% of all responses were generated by the new version of the web API. Let's check what we have in the Podman. We have deployment, our web API, deployment with web API, and deployment with web API Canary. 3 instances, 1 instance. UI basically never knows from where it got its response. Here it got response from the API version 3. If I try to update, it got response from the API version 2. Version 2. Sometime later, if we are lucky, we will have response from the version 3. That's all about Canary deployment. Final deployment strategy is a blue-green deployment. Let's check the main idea behind the blue-green deployment. It's when we have our service and we have couple instances of our old and new applications running together at the same time. For example, here we have UI version 1 up and running with 3 instances. What we'll do, we'll deploy 3 instances of the version 2 of our UI, and then we can switch routing from the version 1 to version 2. In the initial state, we have service getting response from the version 1. In the end, with single switch, all traffic will be routed to the version 2. Let's start our blue-green deployment. For that, as a prerequisite, we need to all our deployment from previous demo be ready. Let's check what we have in our UI application instances. We have 3 UI pods serving UI. We need to do couple preparation before blue and blue-green deployment. We will mark our existing instances version 1 of the UI as blue. Let's see what we have. Okay, we have 3 instances of the UI with a slot blue. Cool. Now let's verify that our UI actually the version 1. As usual, we will change background of our UI application. So let's make version 2 of our front end. For that, we'll go to UI. We will mess with the styles. We'll grab new fancy version of our UI, make it green. With that, we also update version of our UI. In this case, we'll jump to version 2. Cool. Our new version is development ready. We can build version 2 of our front end. UI version 2 is ready. We need to make new image available in the cluster. And let's start our deployment. So we will deploy 3 instances of the new version into Kubernetes cluster. We'll create service for that. And we roll out v2. Let's see what we have in our cluster for the UI application. We have 3 instances of the UI v1 and 3 instances of UI v2. Let's verify the same in Podman. We have deployment UI 3 instances, deployment UI v2 3 instances as well. It's not yet switched to or published yet. What we have right now, our current users use this URI to access our production UI. What we then need to do is to publish v2 via its external port. This is a brand new port we have right now published, 33. If we go to 33, we will see new version of our application. Production users use old one, nobody knows about the new one. We can test, we can do any kind of verifications with a new version, and when we decide that we are ready and we would like to publish new version of the UI, we can just switch with a single command. We switch old new application with a new one. Let's verify what we have at our service level, and we see that our UI is targeted to the slot green. Users will see on the production URI, and it is latest UI version 2. Basically, that's it for the blue-green deployment and for all deployment strategies.